Hey everyone, welcome back to another separate video, and in this video we're going to be looking at the AIME 2021 problem number 1. So let's just read the problem that Zoe and Cho are practicing their 100-meter sprints running 6 races, and Joe wins the first race, and the probability that one of them wins the race is 2/3 if they won the previous race, but 1/3 if they lost the previous race. What is the probability that Joe will win exactly 5 of the 6 races? And the probability will be given in the form m divided by n, and we're asked to find m plus n. Okay, so let's just basically figure out like what the sequence of winning and losing would be first. So the fact that they would win would essentially, the fact that Joe wins the first race is that he would win the first race over here. So we're going to create like a string, and essentially that's going to be categorizing whether or not he won or lost. So he won the first race, but what if he lost the second race? Well, that means he would have to win all these successive races after that, because he wins 5 of the 6 races. And let's say that he lost the third race over here, so it'd be W, W, L, and then he would win the next 3 successive races. And then eventually he keeps losing like the next race, and we do this all the way until we get to 5 successive wins, and then 1 loss. So how can we basically find the probability of this? Well, let's try by finding the probability of the first case over here. So the first case over here, he's guaranteed to win the first one. But since for the second race, he loses in this specific case. He loses the second race. And in order to figure out the probability of him losing the second race, well, we have to figure out the probability of him winning the second race. And as we noticed before, that the probability of him winning the race is 2/3 if he won the previous race, which he did. Which means the probability of him losing is 1/3. So we notice that this probability of him losing in the second race is 1/3. Okay, so now we have to find the probability of winning the next race. Well, he lost the previous race, so it means he only has a 1/3 probability of winning the third race over here. So times 1/3. And then over here we notice, well, that he won the previous race, and he's supposed to win this race, which means that he has a 2/3 chance of winning this race as well. And the same can be said for the next 3 races. So we can just multiply 2/3 by itself, and basically just raise it to the power of 3, because he's going to win the next 3 successive races. Now if we look at this one over here, this case over here, we notice that, well, he's guaranteed to win the first one. And the chances of him winning the second one are 2/3, and that's because he won the previous race. And the chances of him losing the third race over here are 1/3, because he won the previous race. So if he has a 2/3 chance of winning in this case, he must have a 1/3 chance of losing. So 2/3 times 1/3, and then we can use similar logic as previously to explain why the fourth race, him winning the fourth race, gives him a chance of 1/3. And then he wins the next 2 successive races, which means it's 2/3 squared. So we notice a common pattern over here. If there is a losing in the middle of a row of strings, in the middle of the string where there is a succession of wins, then we notice that the probability of him losing at least one of those is going to be 1/3 squared times 2/3 cubed. And he has 4 of those, right? Because he can lose this one over here, this one over here, this one over here, this one over here. So those are 4 of them where the losing is in the middle and not towards the edges. So we can basically multiply this probability by 4 to get basically one part of our answer. So we can do 4 times 1/3 squared times 2/3 squared. Oh, sorry, 2/3 cubed. And then for the last case over here, we need to figure this out. So he has a 2/3 chance of winning this one, a 2/3 chance of winning the next race, and so on. He has like 2/3 chance of winning like the 4 races combined over here, and then he has a 1/3 chance of losing this race over here. So that just gives us a total probability of 2/3 to the 4th times 1/3, and that can be expressed as 16 over 243. So essentially, in order to finally solve our problem, we have to do this this expression over here plus 16 over 243. And the sum of this expression can basically be found as 4 times, well, this is 1/9 times 8/27, which equates to 32 over 243. And when we add 32 to 243 and 16 to 243, we get a total of 48 over 243, which can be simplified to 16 over 81. And since we noticed that we have to find our answer in the form of m plus n, where m and n are the numerator and denominator, Well, we can basically just add these two together, and 16 plus 81 gives us 97, which is our final answer over here to problem number 1.